This is for Algebra 2, Lesson 26 on the hyperbola. Most of the examples I'm going to do are from 26b, so hopefully this will help you get your homework done. But let me start with a more simple one. How about that? I notice they're not so nice on the problems in your actual textbook. Okay, look at this example that I just made up, and here's what I want you to see. This looks a lot like an ellipse. How do I know that? Well, both the x and the y value are squared. It's set equal to 1. These values are different. So it looks like an ellipse. The only difference is instead of adding, I'm subtracting. Okay, so I know this is going to be a hyperbola. Now, the first thing you need to do, just like an ellipse, we're going to graph this exactly the same to get started, is notice your center is 0, 0, because it's what makes the numerator 0 on both sides. So here's your center is 0, 0. And so I'm going to put my little dot right there. That's always where you start, is your center. Now notice under the x is a 25. And remember the x-axis runs horizontally. So what you're going to do is whatever this value is, you're going to take the square root of it. This happens to be a pretty square root. And so this tells me I'm going to go left and right 5 from the center. So I'm going to go over 5 this way, and I'm going to make a little point. And I'm going to go 5 the other direction and make a little point. Now, look under the y is a 16. So whatever this is, take the square root of it, which is 4. Remember, y-axis goes up and down. So from the center, I'm going to go up and down 4. So I'm going to go up this way 4. Let me see if I can clear that up just a little bit. I'm going to go up this way 4 from the center, down 4. Now, if this was an ellipse, I would be done. I would just, connect a nice smooth curve through here, okay? But because it's a hyperbola, it's not any more difficult. It's just a little bit more time consuming. What you're going to do is using these 4 points, you're going to make a rectangle. So just start at one of them, and I'm going to kind of just dot out a little rectangle. And if you have colored pencils or colored pens, this is the time to use it. Make sure, notice I'm making a nice right angle. These points are on the sides of the rectangle. Okay, so let me do that real quick. Oops, I went just a little too far. There we go. Then, after you make your rectangle, you're going to make 2 diagonals. Start here from your center and make sure that you're going through the corners and extend them. What these are, these diagonal lines are called your asymptotes. Your asymptotes are these imaginary lines that your graph will get closer and closer to, but yet never cross or touch. Okay? Right, you're about done. So that looks kind of cool. That's what everybody should look like. Now, what your actual graph is going to look like is you have to come over here. Look to see what comes first. Is it the x or the y? On the ellipse, you're adding and it never matters. Okay, but the subtraction order matters. Since the x comes first, you want to make sure that your hyperbola is going to look more like this. It's going to be split. Okay, if the y would have came first, it would have looked like this. So a hyperbola is just kind of split apart. So since my x comes first, I'm going to use this point on my rectangle, and I'm going to make a nice smooth curve. This is not, and it's going to, notice it's getting close and close to this diagonal line. Remember, that's called an asymptote. It has an arrow, and I'm just going to make a nice smooth curve right like that. So that's kind of what it looks like, and it's also doing that on the other side. So use the point on the rectangle, that's your vertex, and do a nice smooth point. Now, when you watch the Math You See video, if you do, they do all these just by plugging in points. That is totally unnecessary. If you want to do it that way, you can, but this gives a beautiful representation of this graph, okay, without plugging in really any points at all. Now, let's do one of these from your book that aren't quite so pretty. This is from 26b, number 4. And here's why this is not very pretty, is because notice neither one of these are perfect squares. All I can say to that is big deal. Okay, first of all, find your center, and it's going to be 0, 0. That's one thing I have to say is they're very nice about that. I don't know that I'm always going to be so nice next week. Okay, so there's my center. Under the x is a 10. So I want to take the square root of 10. You're going to want to use your calculator for this. So I'm doing that over here on the side. The square root of 10 is about 3.16. So I'm going to write this. It's about 3 point, and I'm going to say 2. Okay, so here's what you're going to do. From the center, I'm going to estimate, but I'm going to go over 3 and just a smidgen more because I'm going over 3.2. 1, 2, 3. So you know what? This isn't any harder just because these aren't perfect. It just means dig out your calculator. Okay, under the y is a 5. So take the square root of 5, and that tells me how far I'm going to go up and down. So I'm coming over here to my calculator. I'm finding the square root of 5, which is about 2.23. You know, that's pretty precise. Who can graph it that precise? So again, I'm going to go up about 2 and then just a little bit more. And I'm going to go down to just a little bit more. Now, since this is a hyperbola, I know that because I'm subtracting, I'm going to make this fancy little rectangle. So I'm going to do this. Whoops. How about if I put my phone so you can actually see what I'm doing? Okay, there's my little rectangle right there. Then do your diagonals. Extend them out a little bit. Remember, these diagonals are called your asymptotes, and they're the imaginary lines that your graph will approach. They're going to get closer and closer to. Okay, it just kind of gives you guidelines of what your hyperbola is going to look like. Okay, after this, you got that little starburst. Come over here and look what's first. Is the x or the y? And you're like, oh, it's the x. So remember, since it's the x, it's going to split to the sides, like that. So I'm going to come over here, and it's going to split to the sides. It's going to look something like this. Should be a nice smooth curve, but I'm doing this with my phone. Let me see if I can do this one a little bit better. Okay, nice smooth curve. Just make sure it's kind of, it looks like it's getting closer to these asymptotes. Okay, like that. So that's kind of what that one would look like right there. Okay, let's do one where the y comes first. And you know what? I am going to do a really yucky one. This is from number 5. This is 26B, number 5. So, first of all, notice so far, these have always equaled 1, which is correct. So, like when you get ready to do number 16, the first thing you're going to want to do is divide everything by 16. So you're going to have this. See, that's going to be what? Y squared over 8 equals 1. And then get started. This is going to be the exact same thing. Just be careful because under the y is a 16. So you're going to go up and down 4. Okay? So from your center, here I said I was going to do number 5 and I got distracted. You're going to go up 4. And you're going to go down 4. Okay? Now, under your x is an 8. So take the square root of 8, which is about 2.8. So I'm going to put here, it's about 2.8. X goes up, x goes back and forth. So you're going to go back and forth about 2.8, which is almost 3. Okay, again, do your little rectangle here, and I'm just going to do this one out real quick. I wasn't going to, but I'm going to. Okay, make your diagonals. Remember what these diagonals are called? They're called your asymptotes. Okay, so there's your diagonals. Try to make it as nice and neat. Now, this is the first one where the y came first. If the y comes first, remember your hyperbola. Hyperbolas are split up, but it opens up and down. So use the point on your rectangle as your vertex, one of your vertexes, and make a nice smooth curve that hugs your asymptote. Okay, and there we go. Here's another one. So it looks just like that. So that's, by the way, I just did number 6 really quick. Okay, so why is 5 so difficult? First of all, it better equal 1. So I'm going to divide everything by 8. So this is what I have. Y squared over 4 minus, now this doesn't simplify, but here's what I'm going to bet most of you may not realize, but you can write this as 8/3. I'm going to bring this coefficient that's in front of the x, because notice so far there's never been, when I'm all done, there's never a coefficient or a number in front of the squared term. So in order just to make graphing easier, whatever's up here, just flip it down. We can talk about in class why that works, but it does. Okay, so there you go. My center is still 0, 0. So I'm going to come over here and I'm going to plot my center. This is under the y. Take the square root of it, square root of 4, that's pretty simple. So since it's under the y and y goes up and down, go up and down 2. So I'm going to go up 2 and down 2. 8/3, take the square root of 8/3. Yeah, it's ugly, who cares? So I'm doing that over here in my calculator real quick. I'm taking the square root of 8/3 and I get about 1.6. Remember x goes back and forth, the x-axis, so go back and forth about 1.6. So it's a little bit more than 1.5. Okay, again, remember if it's an ellipse, if this was adding, you would just do a nice smooth curve through here, but it's our lovely hyperbola, so we're going to do the rectangle. And we're going to do this, do our asymptotes, the diagonals, make sure they're hitting the corners. Okay, now you just have to decide, is it opening up and down or is it opening to the left and right? To know that, you have to look at your original equation. What comes first? Y does. So it's going to open up and down. So it should look like this. Just a little bit more narrow. Okay, that's now our asymptotes help us. Now, if you want to plot points to do this, have fun. Okay, but this is a simple way to do the hyperbola.